This video is going to describe how we can use the arc length formula to find the length of an arc on a circle, find the radius of a circle, or to find the angle involved. What we need to know is that arc length is just an arc of a circle is basically something like this, the distance around part of a circle. So that's one arc. A different arc might look like this. And you've come across these kind of arcs when you took circle geometry back in junior high. The arc length formula that we talk about in Math 30, and it's found on your formula sheet, is arc length equals the radius of the circle times the angle we're measuring in. So A is the arc length, R is the radius of the circle, and theta is the angle that we're using or talking about, but this has to be in radians. And that's one of the most common mistakes that you'll see, is that you'll do this formula and you'll find the arc length, use the radius, but you'll be using the angle in degrees. Your formula will not work in that case. Our angle has to be measured in radians. So let's look at how we can use this formula to actually find the arc length around a circle. Here's our first example. What is the length of the arc subtended by a 130-degree angle if the radius is 6.7 meters? Now there is a new word in there, or one word that you might have seen back in circle geometry is subtended. And we'll talk about that when we make our diagram. So if we look at the circle, they're saying we have a circle and we have a radius of the circle of 6.7 meters, and the angle we're talking about is at 130 degrees. So that's approximately 130 degrees, maybe a little bit more, but there's 130 degrees. This angle subtends that arc. So that's all subtending means. It's opening up to a certain arc on the triangle. So we're trying to find that arc length. The formula that we know is arc length is equal to the radius times the angle. But remember, the angle has to be in radians, and we're given the angle in degrees. So first off, we have to remember that 130 degrees in radians, we just take that, multiply it by pi over 180, and that gives us 130 pi over 180, or in simplest forms, that's 13 pi over 18. That is 130 degrees in radians. So now we can use that in our formula. So the arc length is the radius, 6.7, multiplied by 13 pi over 18. Because again, that angle needs to be in radians. And if we were to use our calculator and multiply that out, and let's say to one decimal place, that's approximately 15.2 meters. So basically that means if we had a circle drawn as here to scale, as this circle is right here, if we were to lay a rope around the edge of this circle right here on 130 degrees, that rope when we stretched out would be 15.2 meters long. Here's the second example we'll talk about. A clock's minute hand is 12 centimeters long. What is the length of the arc created by the end of the hand as it travels from the 2 to the 4? Now, there's a lot of information that you have to think about in this question. However, we've got a clock, and what you need to know is a clock is broken up into 12 sections, but we're actually talking about, we want something like this. We want to know what is the length of that arc from the 2 to the 4. So basically, if this was the center and we have an arm sweeping across there, what is the length of the arm? Well, we know the arm is 12 centimeters, but we need to figure out that angle. All the way around a clock, if it's circular, is 360 degrees. If it's broken into 12 sections, because that's the numbers around the clock, 1 to 12, that tells me it's 30 degrees from, say, 12 to 1, or 1 to 2, or 2 to 3, and so on. But we're actually moving one section, 2 sections. So that's 30 degrees times 2 sections. That means from moving from the 2 to the 4, the clock has to move 60 degrees. Now all we have to do is take that 60 degrees, convert it into radians, because the formula needs that, and we get 60 pi over 180, or that's pi over 3 radians. So now we use that in our arc length formula, and we say the arc length would be the radius, the 12 centimeter arm, times pi over 3, which would mean that that clock in this distance, or the arc created there, is basically 4 pi units long. 4 pi units doesn't mean much to us, but it does tell us, if we take a decimal approximation, that it is 12.6 centimeters along the edge of that clock.